Hari Om. Today we are going to discuss about class 9 mathematics chapter number system. In the number system we are going to discuss about 5 main concepts. The first one is real numbers, the second one is decimal expansion of a real numbers, that is rational numbers and irrational numbers. Third one is representation of irrational numbers on the number line. Fourth one is rationalization of irrational numbers, and the last one is laws of exponents on real numbers. Now we will discuss the first one, that is real numbers. Let's write real numbers. Before we going to start our real numbers, it is very important to know the basic numbers that begins with the natural numbers. Let's start with the natural number, that is the first one, natural numbers. Natural numbers means counting numbers which starts from 1 are called as natural numbers, and capital N is used to indicate the set of natural numbers. Example 1, 2, 3, 4, etc. up to infinity. Let's write example capital N equals to 1, 2, 3, 4 dash dash. Now moving to the second type of a number, that is whole numbers. Whole numbers. Whole numbers means these are also type of a numbers which starts from 0 instead of 1 are called as a whole numbers. It can also be stated as a counting numbers which starts from 0 are called as a whole numbers. Capital W is used to indicate a set of a whole numbers. Example 0, 1, 2, 3, 4 up to infinity. Let's write the examples 0, 1, 2, 3 dash dash up to infinity. Moving to the next third type of a numbers, that is integers. Integers. Integers means a set of or a combination of positive integers, negative integers and 0 are called as a integers, and capital Z is used to indicate a set of integers. Example minus 1, minus 2, minus 3, plus 1, plus 2, plus 3 and 0. Let's write the example capital Z equals to minus 1, minus 3, minus 1, 0, plus 1, plus 2, plus 3. These are the examples of integers. In an integer there are two types of integers, namely positive integers and negative integers. Let's discuss about the types of integers, that is positive integer and negative integers. Positive integers and negative integers. To define positive integers and negative integers, we need to use a number line for the better understanding. So let's write a first or draw a number line 0, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Let's write this one as a right side, this one as a left side. Now let's state or define positive integers. The numbers which are present on the right side of a number line from the 0, that is the numbers which are present on the right side of a number line from the 0 are called as positive integers, and the numbers which are present on the left side of the number line from the 0, the word from the 0 is very important. So I am repeating that the numbers which are present on the left side of the number line from the 0 are called as negative integers. Here examples of a positive integers are plus 1, plus 2, plus 3, and examples of a negative integers are minus 1, minus 2, minus 3. So this is regarding integers, and one more important point is that 0 is neither positive nor negative. So this is regarding all about integers. Moving to the next type of a number, that's very important, that is rational numbers. Rational numbers. Rational numbers means a number which can be expressed or which can be written in the form of a P by Q, where P and Q both must be integers and q, that is denominator, should not be equal to 0. There are two conditions for rational number. The first one is both p and q must be integers and the denominator q should not be equal to 0. Then those type of numbers are called as a rational numbers. I repeat once again, the numbers which can be written or which can be expressed in the form of a p by q, means in the form of numerator and denominator, and the conditions are both p and q must be integers and the denominator q should not be equal to 0. Then those type of numbers are called as a rational numbers. Let's discuss example. Examples: 3, -2, 0.4, 5 by 3, root 4. These are examples of rational numbers. Let's discuss. See here in the definition, I have stated that any numbers which can be expressed in the form of p by q and both p and q must be integers. But in the example, I have written some numbers which are not in the form of p by q and also they are not integers. Then also I am telling that these are rational numbers. Let me explain how, one by one. First, moving to the first one, the number 3. 3 is, first of all, it is not in the form of p by q. So, but 3 can be written in the form of a p by q. How means? 3 equals to 3 by 1. We know that all positive integers can be written in the form of p by q by writing denominator 1. Then it will become a in the form of a p by q, that is numerator and denominator. It can also be written as 6 by 2. 6 by 2 is also equal to 3. Now look at this one. 6 and 2, which is in the form of p by q, and both 6 and 2 are integers and the denominator 2 is not equal to 0. It means that it obeys the laws, that is it obeys the conditions of a rational number. It means that 3 is a rational number. It means that along with that all the positive integers all are rational number. Moving to the second one, that is -2. Here -2 is a negative integer. It is also not in the form of a p by q, but it can also be written in the form of a p by q as we have written 3. Let's write it. -2 can be written as -6 by 3. Now see, -6 and 3 both are integers and written in the form of p by q, and the denominator 3 is not equal to 0. It means that it also obeys the conditions of a rational number. Therefore, -2 is also a rational number. Moving to the next 0.4. 0.4 is not a integer first of all, and it is not in the form of a p by q, but 0.4 it is a decimal number. It can also be written in the form of a p by q. How means? We know that how to convert decimals to fractions. Let's apply that concept over here. So, convert 0.4 into fraction, that is, first we need to write the numerator as it is without a decimal point. It will become a 4, and the denominator first write a 1. Then after that, after the decimal point, count the number of digits. Here after the decimal point only one digit is there, therefore we will write only 10. Then it will become 4 by 10. 4 by 10 is in the form of a p by q. Both 4 and 10 are integers and the 10 is not equal to 0. It means that 0.4 is also a rational number. Moving to the next one, 5 by 3. 5 by 3 is already in the form of a p by q and both are integers and denominator is not equal to 0. Therefore, it is also a rational number. Moving to the last one, root 4. Root 4. Root 4 is not in the form of a p by q and also it is not a integer. But root 4 can be written in the form of a p by q. How means? We know that the square root of 4 is 2 and 2 can be written as 4 by 2. Now see here, 4 by 2 is in the form of a p by q. Both 4 and 2 are integers and the denominator 2 is not equal to 0. It means that root 4 is also a rational number. So, this is regarding a whole rational number. And moving to the last concept or last type of a number, that is irrational numbers. Irrational numbers. Irrational numbers means the numbers which cannot be expressed or the numbers which cannot be written in the form of p by q, where both p and q must be integers and q is not equal to 0, then those type of numbers are called as a irrational numbers. Example, root 5, root 7, root 2, root 3 and pi. These all are examples of irrational numbers. Why root 5, root 7, root 2, root 3 are irrational number, and why root 4 is a rational number means root 4 is a perfect square, therefore it is a rational number. Root 5, root 7, root 3, root 2 are not perfect squares, therefore it cannot be written in the form of integers, therefore these are irrational numbers, and pi is a standard number which is an example of a irrational number. So this is regarding the numbers, basic numbers which comes